students. One of its is 50 unit, that is visible surface detection method. See, visible surface methods are hidden surface removals and it may be closed objects, occupants and other classifications. So there are two types of the classifications. First one is object space method and second one is the image space method. So and also it is called as a hidden removal surfaces. Okay, so visible surface detection or hidden surface removal. Here we are using two different type of the classifications. The first one is the object space method and second one is the image space method. Okay, see, what is object space method? Algorithms to determine which parts of the shapes are to be rendered in 3D coordinates. So, whatever shapes are available, the shapes are to be rendered in the 3D coordinates. Okay. So, methods based on comparison of objects for their 3D positions and dimensions with respect to a viewing of the positions. Okay. So, whenever we compare the different type of the methods based upon the objects in 3D positions and whatever the dimensions are there, that may be respect to the viewing of the positions. Okay. For n objects may be required n by n comparison operations, efficient for small number of objects but difficult to implement. Okay. These are the example of the depth sorting, area subdivision methods. Okay. So this is called as the object space method. Algorithms, so what are the algorithms determine that is the part of the shapes of the rendered in the 3D coordinates and what are the methods of the comparison for an object for their 3D positions and dimensions with respect to the viewing position. So, for taking the number of objects that may be required the n by n comparison from each and every operation. Okay. It may be efficient for small number of objects but difficult to implement on the particular object. So, and depth sorting and area subdivisions are the methods. Okay. These are the examples of the object space methods. Okay. So in image space method, so based on the pixels to be drawn in the 2D. So in here, whenever you can draw the images, complete images are based upon the pixel. So whenever you can draw the 2D, whatever may be, you can draw the images, it may be completely based upon the pixels. Okay. And trying to determine which object should be contributed to the pixels. That is, the running time complexity is the number of pixels times the number of objects. So based upon that, the complexity is the number of the pixels, the times of the number of objects. So space complexity is 2 times the number of pixels. So what is space complexity means? How much space is required to store the particular object? That is called as a space complexity. Okay. So based on the space complexity that may be defined the pixels. See, first one is the one array of pixels for the frame buffer and next one is one array of pixel for the depth buffer. So whenever you can storing the data, it may be dependent upon the two buffers. First one is the frame buffer and next one is the depth buffer. Okay, so that is one pixel value from the buffer value and other value the depth buffer. Okay, covering properties of the surfaces can be used in depth buffer and ray casting methods. Here we are using to the different type of the methods. The first one is the depth buffer and next one is the ray casting methods. Okay, so these are the two techniques for applying the image space method. So in the image space method, all the develop on the projection of the images. In the object method, it may be defined into the directly it will be applied to the object areas. Okay, so these are the two main classification of the visible surface detection method. Okay, the first one is object space method and second one is the image space method. See, and what is a depth key is hidden surfaces are not removed but displayed with the different effects such as intensity, color or shadow for giving the hint for third dimension of the object. So it is the simplest solution is you can use different color intensities based on the dimension of the spaces. Okay. So in the depth key, hidden surfaces are not removed. So these are the hidden. These are hidden faces. You cannot remove them here. Okay. For example, see the one. See, this is the hidden face. Okay, so with different effects such intensity, color, or shadow for giving him the third dimension of the object is. Can give the different type of the colors, whatever may be. Okay, so here we can assume the simplest solution is we can use the different color intensities based on the dimension of the shapes. Okay, in the visual surface detection, we are using the different type of the methods. So the first one is the backface detection method. Second one is the depth buffer method, and third one is the jet buffer and transparency. Okay, the buffer method, scanline method. Okay, these are the main three techniques of using the methods. Okay, first one. So backwards projection. So in the backwards projection, 3D polygon surface is easy. That is, recall the polygon surface equation. That is ax plus by plus cj plus d is less than 0. Then we need to also consider the viewing direction when determining whether a surface is back face or front faces. Okay. So using a back face projection, you can find the what are the front view of the images and what are the back view of the images. Okay. So whenever using the back face projection, you can find the which are the back views and which are the front views. Based upon that, you can find the particular algorithms. Okay. So here we are using the Polygon surface algorithm. Okay, you can define the three surfaces of the algorithm. First one is the ax plus by plus cj plus d equal to 0, ax plus by plus cj plus d less than 0, and ax plus by plus cj greater than 0. Okay, so here you can recall the polygon surface equation, that is ax plus by plus cj plus d less than 0. It is the main of the equation. So we need to also consider the viewing direction and determine whether the surface is back face or front face. So the normal equation is n equal to a comma b comma c. C. A polygon surface is back face, then v n greater than 0. However, remember that after application of v conservation, we are looking down the negative z axis. Therefore, the polygon is back face if 0 comma 0 minus 1 into n greater than 0 or if c less than 0. Based on that, we can find the particular algorithm. Okay. So here C. So this is the n equal to ABC. This is the backbone of the equation. Then viewing of the z direction. So viewing of the z direction may be dependent upon the particular algorithm. So we will also be unable to see surfaces with c equal to 0. Therefore, we can identify a polygon surface as a backface if c less than or equal to 0. So based upon that, we can identify the which is the backface direction, which is the identify the particular algorithms. Okay. So already we discussed the classic. So what are the backface? How we can identify the backface directions? Okay. C. So backward detection can identify all the hidden surfaces in a scene that contain non-overlapping convex polyhedra. So, but we have to apply more tests that contain overlapping objects along the lines of the site to determine which objects obscure which of the objects. So, in the backward detection, we can identify what are the hidden surfaces. That is, what are the backside of the surfaces. Okay. So in that scene that contain non-overlapping convex, here there is no non-overlapping of the convex polyhedra, but we have to apply more tests that contain overlapping objects along the line of sight to determine which objects obscure the objects. So these are the backspace method. So we using of the backspace method, we can identify the which are the backspace of the lines. So main the backspace distinction is using of the ax plus by plus cj to be less than 0. Then you can identify it as a backspace. And also another is v into n. There is a viewing position and is there normal coordinates. Based on normal coordinates and viewing position, it may be using for z axis, that is 0 comma 0 comma minus 1 into n greater than 0, or if c less than 0, that is n equal to a comma b comma c, and using z axis that equal to also unable to see surface is equal to 0. So therefore we can identify polygon surface as a backface if c less than or equal to 0. Okay. So the backface digital can identify all the hidden surfaces in a scene that contain non-overlapping convex polyhedras. So but we have to apply more tests that contain overlapping objects along the line of sight to determine which objects obscure which objects. Okay. So, and next one is the depth buffer method. So, what is the depth buffer method? See, also known as the depth buffer method. It is an image space approach. So, it is called as image space approach. And see this one. So, backwards method is called the object space method. So, this is an object space method. So, backwards is called as the object space method. So, these are all can allocate to the objects. In depth buffer, it is called as the Z buffer method or G buffer method. Okay, so it is also it is an image space approaches. Okay, so each surface is processed separately, one pixel position at a time across the surface. So here, each surface is processed by separately one pixel position at a time across the surfaces. When you can draw the lines, you can identify each pixel of the particular surfaces. The depth value for a pixel are compared and the closest to the smallest Z value surface determines the color to be displayed in the frame buffer. So applied very efficiently on polygon surfaces and surfaces are processed in any order. Okay, so it is known as a Z buffer method. It is an image space approach. Each surface is processed separately, one pixel position at a time. Okay, the depth values for a pixel are compared and the closest surface determines the color to be displayed in the frame buffer. Applied very efficiently on polygon surfaces. Surfaces are processed in any order. See here, this is the XYZ. With the base of point XYZ, we can allocate to the XY view plane. Then view plane we can allocate to the S1, this is S2, and this is S3. Okay, here we can allocate it to X1, Y1, Z1, then X2, Y2, Z2, X3, Y3, Z3. Okay, so based upon it, we can calculate the Z value. That is called as the smallest Z. So which is the closest surface determine the color to be displayed in particular frame buffer. So now we can find the which is the smallest value of the surface determine the color in the particular view plane. It may be S1, maybe S2, or maybe S3. Okay, so based upon the Z view direction. So based upon the Z view direction, you can find the S1, S2, and S3. Okay. See, here, whenever we can assign the Z1, Z2, Z3, we can store the values in the particular area. That is the two buffers are used, we can store the data. That is the frame buffer and depth buffer on visual surface methods. That is, we are using to the Z values and that one we are using to the intensity values. So whatever intensity values are there, the values will be stored in the particular areas. Okay. See, the Z coordinate, there is a depth values are usually normally in the range of 0, 1. So in the values of 0 and 1, we will find the depth values. So the Z coordinate, what are the Z coordinates means we can using it to the genuine operations. So there are usually normalized to the range of 0 and 1. So here we have find the different of the algorithms. There is a depth buffer algorithm. The first step is initialize the depth buffer and the frame buffer so that for all the buffer positions is x comma 1. So depth buffer x comma y equal to 1 and frame of x comma equal to basic color. That is the intensity values we are stored in the particular frame buffer. Okay. So initial equal to 1 and remaining. Whenever we can change the direction, that is d less than z less than 0, z greater than 0, the depth buffer is changed the value that equal to z. Okay. So process each polygon is seen on eclipse time c. For each projected x comma y pixel position of a polygon, calculate the depth z. If z less than depth buffer of x comma y, it computes the surface color of that position and set. Depth buffer of x comma y equal to z and frame buffer of x comma equal to surface color of x comma y. Okay, so whenever the z less than depth buffer, then it will be changed from depth buffer value 1 to z or maybe 0 to z. That equal depth buffer of x comma y equal to z, frame buffer of x comma y equal to surface color of x comma y. Okay, that is equal in frame buffer we are storing to the intensity values of the particular frame buffers. See how we can calculate the depth values of efficiently. We are using to the equation ax plus 3y plus 3z plus d equal to 0. See, we know the depth values at the vertices. How can we calculate the depth at any other point on the surface of the polygon? Using the polygon surface equation, that is z equal to minus ax minus by minus d by c. So based upon this equation, we can calculate the z values. Okay, but here you can take any scan lines for the vertically or horizontally, maybe calculate the x plus 1 comma y minus 1 values. Based upon that, you can find the z value. See, for any scan line adjacent horizontal x position or vertical y positions differ by 1 unit. So the depth value of the next position x plus 1 comma y on the scan line can be obtained using z dash equal to minus of a of x plus 1 minus by minus t. That is, you can take the position of x plus 1 y. Okay, that is minus a of x plus 1 minus by minus t by c, that equal to z minus a by c. See, for adjacent scan lines, we can compute the x value using the slope of the projector line. So when you use the slope of the projector line, the previous of the x value, that is x dash equal to x minus 1 by n, that is z dash equal to z plus a by n plus b by c. Okay, so it is able to handle the cases such as this is the P1 and P2 and v front of the line is P1 P2. So these polygons are both inflated behind of the one another. So we may want to render transparent surfaces with the jet buffer. However, we must render in back to front order. Otherwise, we would have to store at least the first opaque polygon behind the transparent one. See here, first one, second, and third is a partially transparent. See, first must recall color and depth. That is the probability ordering, and need depth of first and second, and front of first and second. When very overlapping, then we can go for the different of the operations. Okay, so extends the depth buffer algorithm so that each position of the buffer can reference a linked list of surfaces. More memory is required. So, however, we can correctly compose the different surface colors and handle the transparent of the surfaces. Based on that, we can assign to the different surfaces colors and different of the handling transparency of surfaces. We can refer to the high memory. In that way, each position in the A buffer has two fields. First one, depth field, and second one is surface data field. So here we are using to the each and every buffer has the two positions. The first one is a depth field and second one is a surface data field. So that is, which can be either surface data or a pointer to a linked list of surfaces that contribute to that pixel positions. See here. So depth greater than or equal to 0. The next one is the RGB and other information. And next one is depth less than 0. Then it will be surface 1 information, then surface 2 information, and so on. So it may be depending on the surfaces, then you are going to the field of the linked list. It may be operation of the linked list, that is depth less than 0. It may be linked to the surface 1 information, then it will be linked to surface 2 information, then it will link to surface 2, 3 information. Okay. So likewise we have to define the jet buffer methods. Okay. So these are the two methods. First one is the depth buffer. Sorry, backface registration method. Using the backface registration method, we can find the which are the invisible and visible surfaces. Okay. If ax plus by plus cj plus d less than 0, it is invisible, but there is a backside of the form. Now we can calculate the backside and remove it. That is, we can detect and remove it. And another condition bn greater than equal to 0. If viewing position in normal vectors, if it is a positive, then we can detect the backside of this and remove the particular condition. So likewise, it is called as the backface rejection. In depth of buffer, we can identify the what is the closest surface values of the particular giving a frame buffer. In here, you can store the values using of the two buffers. First one is the frame buffer and depth buffer. In the frame depth buffer, we are storing the depth values of the particular area. In the frame buffer, we are storing the intensity values of the particular surface also. Initially, the depth buffer is equal to 0 or 1. Whenever z is less than depth buffer, then it will assign to the z value, and frame buffer equal to always be surface color of x comma y. So calculating depth values efficiently, we are into three equations. There is a base of z, there is a polygon table z equal to minus ax minus difference d and c. Using of these some scan lines that based upon that we can find z minus a by c and z dash equal to z plus a by n plus b by c and x dash equal to x minus 1. So whenever a by equal to vertically a by is infinity, then z by you can calculate by a by n, then x dash equal to z plus b by c. Okay. So these are examples. So in each position of the buffer has two fields. First one is the depth field and second is the surface data field. Based on that, we can find the value. There is a depth greater than or equal to 0, RGB and other information. Depth less than 0, it will link to the surface information. It link to the surface 2 information. Okay, these are the two methods of the visible surface detection. The first one is the backface detection and another one is the depth or Z buffer method or G buffer methods. Okay. So backface detection is a object-based method and depth buffer is the image space approaches. Okay, so in image space approach, we can find the projection of the images. Okay, next one. So next one is the scanline algorithm. See, extension of the scanlines algorithm for filling the polygon interiors. It is simply we can say it is an extension of 2D scanline algorithm. Okay, or extension of the scanline algorithm for filling the polygon interiors. Okay, for all polygon intersecting each scanline, that is proceed to from left to right and depth calculations for each overlapping surface. Next, the intensity of the nearest position is entered into the refresh buffer. So based upon that, we can find the scanline algorithms. Okay. See, in the scanline algorithm, we are defining the different type of the tables. First one is the edge table, second one is the polygon table, and third one is the active edge table. Okay. See, first one is edge table, polygon table, active edge table. In the edge table, the coordinate endpoints for each line and the slope of the each line and pointer to the polygon table and identify the surface bound of each line. In the edge table, we can identify the x value, that is a coordinate value, slope value, that is delta x value, then ID, that is a polygon ID. This is on which polygon you are using to identify the edge tables. Okay. The next one, polygon table. So, coefficients of the plane equation for each surface intensity information for the surfaces. So, point to the edge table. Here you can identify the polygon ID. Next, next intensity values, polygon values, and in or out places. That is which are the point of the inside of the view and which are the outside of the views. Okay, now in that way, in edge table, polygon table will be assigned. So edge table, coordinate endpoints of each line, slope of each line, point to the polygon table. In polygon table, coefficients of the plane equation, intensity information for the surfaces, pointers into the edge table. Then go for the active list and flag. That is the active list contain only edges across the current scan line sorted in order and increasing of x and flag for each surface indicate whether inside or outside of the surface at most the leftmost boundary of the surface. The surface flag is turned on at the rightmost boundary of the surface. The surface flag is turned off. So in the active list we can assign to them what are the intersect points of the particular scan. Whenever you can traverse scan lines, what are the intersect points of there that will be assigned to the activities? That is contain contain the edge crosses the current scan line. So based upon we can find the what are the intersect points. Based upon intersect point, we can assign the which is the inside of the view, which is the outside of the view of the particular list. Okay. So already we have discussed some examples on the particular scanline method. So in the scanline method, mainly we are using to the three tables. So the first one is the edge table, second one is the polygon table, third one is the active list table. Okay. So these are the main three methods. First one is the backface reduction method, second one is the depth buffer method, and third one is the scan line method. And remaining are um, depth sorting method, area filling method, wireframe method. The next one is DSP, which is the binary space tree method. Okay. So next class we will discuss the binary space tree method, um, depth sorting method, and next one is the area filling method and wireframe methods. Okay. Thank you.